In this video, we're going to be discussing a phenomenon known as capillarity. So in general, as we've mentioned before, soil below the groundwater table is usually considered fully saturated, so S equals 1. And then a big simplification we also make in a lot of calculations, especially in foundation design calculations, is that soil above the groundwater table is completely dry, which is S equals 0. But this is, again, really a simplification, and it's not really the reality. So this is where this idea of capillarity comes into play. So what is this? Well, this is a phenomenon you've actually seen in one form or another in this class and in some previous classes as well. So capillarity is the upward movement of a liquid into the vadose zone. So if you remember, the vadose zone is the region that's above the groundwater table from our one of our previous videos. Okay, so this upward movement is a result of surface tension that develops. Okay, so we're going to write capillarity is a result of surface tension at the air, water, soil, grain interfaces. Okay? Now, it turns out we see this phenomenon of capillarity in another setting, or we have seen it before in another setting. So it turns out that that this can also occur when water rises in small glass tubes or containers. Okay, so where we've seen this before is either a hydraulics or a fluid mechanics setting, where you put a glass tube in a container of water and you see the water rise up in the glass tube above the static water level that you put the tube in. Okay, so let's take a look at this from just a fluid mechanics or hydraulics perspective. So for pure water in a clean glass tube at 20 degrees Celsius, the height of capillary rise is given as the following. H equals negative 0.03 over little d, and this comes out in units of meters. And little d is the glass tube diameter in millimeters. So this is a semi-empirical calculation, so you got to be very careful. Little d has to go in millimeters, and the whole term comes out in meters. The negative indicates the directionality of rise. So negative would be indicating that the water is rising above the original water level where you had zero pressure. So let's draw a little diagram of this. So let's say we have a water level here, and there's our glass tube. And again, here's our water level. And of course, at the water surface, there is zero pressure. So put zero pressure at water surface, okay? And the diameter of this tube is little d. And so what happens is this water is going to rise up in this glass tube. And measuring from the bottom of the meniscus to the original water level, this is that height h right here. Okay, so this height h is being measured from the original water surface where you have zero pressure up to the bottom of the meniscus where it rises inside of that glass tube. Okay, so of course, you know, this is a pretty simple calculation. You just need to be very careful with your units. Again, little d has units of millimeters, and then the whole term comes out in units of meters. Now, this is for a glass tube. What about in soil? What about in soil? So for soils, Terzaghi et al. In 1996 proposed the following. So for soils, you'll have H equals little c over E D10. And this also comes out in meters, okay? Now, little c is an empirical coefficient. It's an empirical coefficient varying from 0.01 to 0.05, okay? Now, for C values, if you're not given a C value directly, then you can just take an average and just maybe, or pick a reasonable value depending on other information you may have about the soil between 0.01 and 0.05. E, of course, is void ratio. And then D10 is your effective grain size. In millimeters, okay? Now, so again, pretty simple relationship. You just got to be careful with your input values. Another thing to keep in mind, or that I like to point out, is remember Terzaghi passed away a long time ago. Terzaghi died in the 1960s. So this was published in 1996, which means that Terzaghi had been dead for 30 or so years after this was published. So what happened was he did a lot of this early work before he had died, and then others, remember the et al. Means and others, continued the work and then still listed him as the main publishing author when this eventually was published in 1996. And that's going to conclude this video.